Hi, I'm Tom. I'm going to be the coordinator for the group. This means I'll be in charge of making sure everyone's available to come together and making sure that the design fits with the manufacturing, looking over materials and making sure everything comes together in a good way.
Hi, my name's Logan. I am the designer for this part of the project. Which means I've looked at other people's designs and see if I can adapt them to fit our criteria, which most of them do.
My name is Jason. I'm going to be in charge of manufacturing and costing for the project, basically looking at where to source parts, how to source them, and if it's going to be feasible.
Hi, I'm Danny. I'll be doing the manufacturing side of our design projects, so I'll be looking at the best ways and the best materials and sort of how to put everything together, and hopefully we can win.
As a designer, each concept was handed off to me in the form of a rough sketch, which I then translated into a SolidWorks assembly and animated the explode of them, just to illustrate what each design consisted of.
For concept A, I began with a flat three-wheeled system, basically for ease of mounting motors and battery packs. One of the problems I ran into halfway through is the stability and the moment created by one of the driven wheels, which is why I added 2 more wheels elevated above the initial design. One of the issues that I then ran into is how to mount the battery pack and motor, which is why it is classified as one of the more detailed designs and in turn difficult.
For concept B, I looked at various designs available on the internet and found the most simple that seemed like it would be the most effective. To do this, I made it so that there was 4 wheels, 2 on either side of the design, and a motor in between with a battery pack on the opposite side to the motor to counterbalance it. This seems to be the most simplistic design, which in terms of engineering is not a bad thing, because over-engineering certain project designs leads to aspects later down the road that would require more complex problem solving. This would be avoided with the most simple design.
For concept C, I decided to design a device which would have the majority of the weight in the centre, as well as having 4 wheels on the sides. This is for stability. One of the problems with this concept was how to run the powertrain through the system and drive all the wheels. Also, as the tube would be circular, it'd be more complex to get the dimensions right so that the wheels would stay in contact with the tube at all times.
With concept D, I decided to start off with a main platform with a wheel either side that could be driven, and with this platform it would make it easier to mount the battery and the possible 2 motors to drive them. Either side of that was 2 spring-loaded ideas to keep the arms pushed out against the sides to help with stability. Although this design has potential, it is unfortunately quite a tricky design and possibly expensive to manufacture, therefore it might not be the chosen one.
After all the designs were completed, we created a list of fundamental features that the designs would be compared against. We believed that reliability, completion of the task, and simplicity would be our biggest factors when choosing a design. Now, after comparing all the designs, we concluded that design B was our clear winner due to the overall simplistic design.